Right, my dear children. So we discussed what are the theoretical parts related to the sound lesson, and now we are going to discuss some activities and some exercises related to the sound lesson. So it's really important that you follow up with these given exercises, and you should have to answer these things first. You should have to answer these things first before I'm going to answer it. So this is just a discussion to check whether you have got the correct answers. Right, now we'll move on with the questions. So first of all, you are given with exercises from your textbook to see what are the answers for these questions. Right, so in this first case, you have to select the appropriate words from the brackets and need to fill the blanks. So in the first question, sound of high frequency. Sound of high frequency. Sound of high frequency. Sound of high frequency can be obtained when the wires of a violin are a blank. So here we need to select the term or the word that can produce a high sound or else a more intense sound of a violin. So the words are given as shorter and longer. So high frequency sound can be obtained in a violin, right? Violin is a musical instrument which produces sound by the vibration of strings. So when the vibration of the strings are shorter, so in that situation, the frequency of the generated sound is very high. So sound of high frequency can be obtained when the wires of a violin are shorter. When the wires or the strings of the violin is shorter, we can hear high frequency sounds. So high frequency sounds can be obtained when the wires of a violin are shorter. Right. The next question. Sound of high frequency. Once again, you are given with high frequency. So sound of high frequency can be obtained when the membrane of a drum. Now when you take a drum, when the membrane has more tension, it produces high sound. When the membrane has more tension, when the membrane is stretched, when the membrane is tightened, you can hear a sharp sound. It's because in that situation the frequency is high. So sound of high frequency can be obtained when the membrane of a drum is, now the words which is given in here is thin or thick. Thin or thick. So here the tension is not given, my dear children. The tension is not given. But we know that, we studied that if you take a guitar, when increasing the thickness, the frequency of vibration decrease. So the same principle can be applied to here as well. When the thickness is high in a drum membrane, the frequency decrease. I told you that when we are discussing the lesson, thickness and the frequency are oppositely related. When increase in the thickness, frequency reduce. When decrease in the thickness, frequency increase. So sound of high frequency can be obtained when the membrane of a drum is thin, right? When the membrane of a drum is thin. So we can choose the word thinner for the blank. So for the blank, we can use the word thinner. That's the correct answer. So the sound of high frequency can be obtained when the membrane of a drum is thin or is thinner. Question number 3. Human ear is sensitive, not sensitive to any range of sound. By doing an activity using a hacksaw blade, we discussed that we can't hear all the sounds in our environment. We can hear up to a certain range of frequencies. So in this question, the human ear is sensitive or not sensitive to any range of sound. So the correct answer would be it's not sensitive. Human ear is not sensitive to any range of sound. We can hear only certain range. That range is from 20 Hertz to 20,000 Hertz. So not sensitive is the correct answer. Not sensitive. Human ear is not sensitive to any range of sound. Next one. Vibrations of an object is blank, regular, irregular when musical tones are produced. Right. So I told you that musical tones or music is produced at regular intervals by arranging vibrations at regular intervals to a wonderful pattern. That's how the music is being produced. So in this question, it's obvious to us, vibrations of an object is regular when musical tones are produced. It should be regular. 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 So vibrations of an object is regular when musical tones are produced. When producing musical tones, we use regular vibrations of an object. Right. Now we'll move on with the next question. So the second exercise from your textbook is categorize the musical instruments given below into 3 groups according to the way they produce sound. According to the way they produce sound, we need to categorize these instruments. Right? Need to categorize these instruments. So there are 3 categories mainly. So we need to categorize these instruments according to those 3 categories. Right. So I'll take the slide somewhat up. I'll take the slide somewhat up. So now let's divide into 3 groups. We'll divide into 3 groups. right? So now I am going to name these each columns. So once again, so I am going to divide this thing into 3 columns. So now we'll go to categorize each thing. So let's categorize. So here, by vibrating strings. Then in the next one, by vibrating membrane. The third one, by vibrating air column. By vibrating air column. Right. So let's divide now. I'll use different color. So the first one is the double drum or the thumb metronome. So when it is going to be a drum, we know that it has a membrane to produce sound. So by vibration of a membrane, the sound is produced in thumb metronome or else in double drum. So double drum. Double drum. So double drum is producing sound by vibrating membrane. Next one. So we can cut double drum in here. Thumb metronome. I'll cut that thing. Then the next one is given udakkiya. Udakkiya is a traditional musical instrument which is unique to Sri Lanka. Right? Udakkiya is a traditional musical instrument in Sri Lanka, an ancient one, a traditional one. So it's like this. I can draw a rough diagram within this column, right? Then I'll erase it when I'm going to do the division. So it is like this. It has two cylindrical shapes, conical shapes like this, and there are several lines through it. And now the special part is this whole is being covered by a membrane, a skin membrane of an animal. Right. So by tapping on this, we produce sound. Okay, by tapping on this, we produce sound. Right. So udakkiya is like this kind of a instrument. So here also we produce sound by tapping on the membrane of the udakkiya. Right. So udakkiya is a musical instrument. Udakkiya is a musical instrument which produces sound by the vibration of membrane. So it's going to produce sound by the vibration of membrane. So the second one is udakkiya. Udakkiya. So we'll cut udakkiya in here. Then the next thing is horanäva. So I told you that when you are doing the lesson, horanäva or the trumpet, right? Traditional trumpet in Sri Lanka, right? We blow it like a flute, the traditional trumpet, right? It's like a trumpet. So it produces sound by the vibration of air columns. So hornave. Hornave is an instrument which produces sound by vibration of air column. Then next one is sitar, the traditional Indian musical instrument which produces sound by the vibration of strings, right? Produce sound by the vibration of strings. So sitar by vibration of strings. Sitar by vibration of strings. And we'll cut sitar also. Then the trumpet. So traditional trumpet is hornave. I told you that it belongs to the vibration of air columns. Then trumpet also belong to the same category. It produces sound by the vibration of air columns. So trumpet. Trumpet. Then conch shell. Conch shell. Brackets. In brackets, you are given with the Sinhala term for the conch shell. What is that? Haggediya. So for conch shell also, you blow air particles, right? In opening ceremonies, in traditional festivals, the conch shell is being used. So here also, we use air particles, the vibration of air particles to produce sound. So conch shell. Conch shell produce sound by the vibration of air particles or air column. Then violin. Violin, you know what's the violin is. We play violin, we vibrate the strings. So violin is an instrument which produces sound by the vibration of strings. Violin. Violin. Then the next one is cello. So cello is also a musical instrument which produces sound by the vibration of strings. Cello is also a musical instrument that produces sound by the vibration of strings. It's same as the violin but somewhat larger, right? Somewhat larger than the violin. So cello. Then the mandolin. Mandolin. Mandolin also produce sound by the vibration of strings. Mandolin also going to produce sound by the vibration of strings. It's also like a type of a guitar, right? Like a type of guitar. It's produce sound by the vibration of strings. So the next one is mandolin. Mandolin. Then finally we have the large drum or the dowler. Dowler. So dowler is a drum. So you know how does the drum is going to produce sound by the vibration of a membrane. So the next one is large drum. So we have divided these musical instrument into the three categories: by vibrating strings, vibration of a membrane, and by vibrating air column. So sitar, violin, cello and mandolin, those four belongs to the vibration of strings. Double drum, udakkiya and large drum belongs to vibration of a membrane. Hornave, trumpet and conch shell belongs to vibration of air columns. Right. Now, these are the two activities given in your textbook, my dear children. So now we'll move on with the next some additional questions which I have provided to you guys. Right. So if the statements given below are correct, put a tick, and if they are wrong, put a cross in the brackets. So you have to put a tick or else a cross in the bracket. When the wires of a violin are tightly stretched, it gives a low tone. When wires of a violin are tightly stretched, when it is tightly stretched, the tension of the string or the wire will increase. Tension of the wire will increase when it is tightly stretched. Tension will increase. So, when wires of a violin are tightly stretched, it gives not low, it gives a high tone. It should give a high tone because when increase in the frequency, a high tone is getting produced. So, when the wires of a violin are tightly stretched, it gives not a low tone or a low sound, it gives a high sound. So, this is incorrect. This statement is incorrect. Next one. When the length of the vibrating air column is less, see, length of vibrating air column is less, it gives sound of low frequency. When the length of vibrating air column is less, there are less number of air particles, no? So, if the number of air particles are less, it's quite easy to vibrate those things. Because if the number of air particles are less, then it's easy to vibrate. Number of oscillations will increase. If the number of air particles are less, number of oscillations will increase. So, when increase in the number of oscillations, the number of vibrations also increase, means that the frequency is going to definitely increase. So, if the frequency is going to increase, the sound which is produced is also very high, very sharp. So, in here, the second statement, they are saying that when the length of the vibrating air column is less, when the length is less, number of air particles are also less, means that they will vibrate quite fast, means that frequency is high. That means, my dear children, intensity of the sound is not less, it should be high. So, it gives not a less frequency, it provides a greater frequency. So, this statement is also incorrect. This statement is also incorrect because the length of the vibrating air column is less, then it produces a high frequency sound. Then the third one, xylophone is an instrument that produces sound by vibrating bars. That's correct. That's obviously correct. We know that xylophone, it uses different lengths, metals with different lengths. So, we need to tap on each bar to produce sound. So, when tapping, sound is getting produced. So, it is correct. Fourth one, some mental depression conditions of patients can be cured by musical therapy. Some mental depressions and conditions of patients can be cured by musical therapy. So, yes, indeed we can use musical therapy in treating these kinds of diseases, defects. So, we discussed that mostly we use musical therapy to treat mental disorders and to have a good concentration and to have good mental focus. So, it is correct. We use musical therapy for the conditions of mental depression. So, it is correct. Right. So, these are the answers for third question. Right, then we'll move on with the next one to see what are the other contents. Right, you are given several multiple choice questions. You know that in your test paper you will be receiving 20 multiple choice questions, MCQs. So it's really important to have some knowledge on how to select in a better answer for your MCQ questions. We'll see what are the questions related to MCQ questions related to sound part. Okay. So first question. The musical instrument that do not produce sound by vibration of strings. That do not produce sound by vibration of strings. So remember, do not. So my dear children, you have to be careful when you are reading the question. Read the question 2 or 3 times before selecting an answer, because in MCQ questions, they are given with questions like these. You are given with question like these. Sometimes they are asking about not or negatives. Sometimes they are asking about yes, I mean the positives. So in that situation, you have to correctly select the better answer. Right. So musical instrument that do not produce sound by vibration of strings. Do not produce sound. First one is piano. Piano is like an organ, no? It's a large instrument. It's like organ. It has keys. So when playing the keys, the sound is getting emitted from the piano. When playing a certain key in a piano, there is a metal bar like this, which is going to hit on another metal bar like this, and it's going to emit sound. So piano is an instrument which vibrates a metal piece to emit sound. So musical instrument that do not produce sound by the vibration of strings. So piano answer is incorrect, as it is asking about a do not, a negative one. Next one, guitar. Guitar is an obvious answer, so we know that it is incorrect. Guitar produce sound by the vibration of strings. Number 3, sitar. Sitar is also the same thing, right? Sitar is the traditional Indian musical instrument. It produces sound by the vibration of strings, so it is also incorrect. So the answer should be the fourth one. Let's see. Serpina. Serpina or the harmonium, right? Serpina is an instrument. We give air particles by pushing and pulling that part after the serpina, the playing part. Then we blow air particles into it and we play the sound. So serpina, upon blowing air particles, it is going to produce sound. So it's a musical instrument which produces sound by the vibration of air columns. So my answer is serpina. Second one, instance where tuning fork is used. Instance where tuning fork is used. You know that there are several tuning forks with several lengths, right? Like this, there are several tuning forks in our laboratory. Several tuning forks with several lengths. So I told you that the frequency is being printed on the base of the tuning fork. So when you vibrate the tuning fork, you can hear the sound, and also you can get the idea of the frequency of that vibration. So let's see. Instance where tuning fork is used. Number 1, to detect defects in the ear. Absolutely, that's my answer. It's because that I told you frequency is printed on each of the tuning forks. So when it is vibrating, the sound is going to emit and we can see the frequency printed on the base. So we can get several tuning forks and we are going to vibrate it. Then by that way, if a certain patient can't hear that sound, means he has a defective ear, right? He has a defective ear. So we can conclude the diseases, or we can come into conclusion with the diseases associated with the ear by using a tuning fork. So that's my answer, but we'll look at the other answers as well. Second one, musical therapy, instance where tuning fork is used. Now tuning forks are not used in musical therapy, no. In musical therapy we use sound or pleasant music, right? Third one, to produce music. We can't use a tuning fork to produce music. We just can vibrate it to emit a certain sound. So we can't produce music from it. Number 4, in surgeries. We can't use tuning forks in surgeries. So the correct answer is what? To detect defects in ear. To detect defects in ear. Right. Question number 3. International Standard Unit to measure frequency. International Standard Unit to measure frequency. Number 1, watt. No. Number 2, Pascal. No, that's not the answer either. Number 3, Hertz. Now that's my answer. International Standard Unit to measure frequency is Hertz. International Standard Unit is Hertz. Right. Newton, that's also incorrect. We don't use newtons to measure frequency. We use what? Hertz. Number 4. A blank is given, is going to produce sound by vibration of membrane. Produce sound by vibration of membrane. So we need to select a musical instrument from the given list that produce sound by the vibration of a membrane. We'll see. Drum. Large drum. Udakir. Above all. So we know that each and every drum is going to produce sound by the vibration of a membrane. And I told you earlier, Udakir is also a musical instrument which do the same thing to produce sound, which follows the same thing like drums to produce sound. So Udakir also produce sound by the vibration of membrane. So therefore, all of these things are correct for the blank which produce sound by the vibration of a membrane. Right. Move on with the next thing then. When increasing the thickness of a string in guitar, when increasing the thickness, so once again, thickness and frequency, oppositely related quantities. Thickness and the frequency. When thickness increases, frequency drops. When thickness drops, frequency increases. So we'll see. When increasing the thickness of a string in a guitar, frequency increases. When increasing the thickness, actually the frequency is going to decrease. So my answer would be frequency is going to not increase, but it's going to decrease. So when increasing the thickness of a string, the frequency decreases. In the third one, frequency do not change. It's incorrect. We know that when increasing the thickness or when decreasing the thickness, the frequency is going to definitely change in a guitar. And none of the above, right? These answers are correct. Next one. A tuning fork vibrates. I'll take this thing somewhat up because there is in this question we have to do some calculation. So a tuning fork vibrates 240 times within 2 minutes. Within 2 minutes, this tuning fork is going to vibrate 240 times. So the question is, what is the frequency? So let's remind what is the formula to find out frequency. Let's remind what is the formula to find out frequency. So frequency is equal to number of vibrations frequency is equal to number of vibrations division the time taken. Always remember, when you are going to measure the time should be in seconds. It's a compulsory thing. The time should be in seconds. So it is given that within 2 minutes. The question is given within 2 minutes. So the question is given from minutes. So definitely you need to convert that minute thing into seconds. So we'll convert minute thing into seconds first. So 2 minutes means 2 minutes is equal to 2 times of 60 seconds, means altogether 120 seconds. 120 seconds. So within 2 minutes there are 120 seconds. So now let's apply with the formula to get the answer. So number of vibrations. How much is the number of vibrations? 240. Division. How much is my time taken in seconds? 120. 120. So you can cut 0 to 0 here. So here 12, when you divide 24 by 12, my answer is 2. So answer should be 2. The frequency is measured from hertz. So answer is 2 hertz. So where is that answer? In the third response, you can observe that 2 hertz thing. So the answer is 2 hertz. Right. Dear children, please remember, when substituting the time period, it should be in seconds. So to trick you, the responses will be definitely given from the minute by substituting the minute time as well. So see, if you divide 240 by 2 minutes, the answer would become 120. In these responses, the first choice is given as 120. So you might get wrong if you substitute with the minutes time. So please remember, when you are doing this thing, you definitely need to remember this thing. When you are selecting the time, select the seconds or convert into seconds and then substitute with the formula. If you are given with minute values, you need to remember that thing before you are going to do any kind of calculation. Okay, right. Now let's move on with the next question then. Frequency of a drum can be increased. Frequency of a drum can be increased. Frequency of a drum can be increased by using 2 different ways. One thing, we can increase the tension. By increasing the tension, we can increase the frequency of a drum. And the second thing is, we can use a thinner membrane. So we'll see the responses. By increasing the tension of the membrane, the first one is absolutely true. We can increase the tension of the membrane to increase the frequency of a drum. we can increase the frequency of a membrane, frequency of a drum by increasing the tension of a membrane. So, here frequency of a drum can be increased by increasing the tension of the membrane. Let's see the other answers as well, my dear children. So, in the second one, by loosening the membrane. If you loosen the membrane, then the tension would reduce. Tightness will reduce. When loosening the membrane, tightness is going to reduce. If tightness is going to reduce, then the frequency is also reduced. So, it is incorrect. Third one, by decreasing the tension. The same answer. Loosening means decreasing the tensions. So, it is also incorrect. And the fourth one, from above all. All of these instances can be used to change the frequency. But especially when increasing frequency, we need to increase the tension. So, that answer is also incorrect. So, the correct answer is first one, by increasing the tension of the membrane. Question number 8. Musical therapy is not used. Once again, there is a negative one. So, we need to select an instance which the musical therapy is not being used. Okay. So, when doing aerobics means those physical exercises which we do to a certain rhythm. So, it is correct. So, second one, to treat patients with diabetes. If a certain patient has diabetes, the diabetes conditions cannot be cured by using musical therapy. We studied that musical therapy can be used to treat patients that has nerve disabilities or else mental issues. So, diabetes is a physical condition. Diabetes is a physical condition. It's going to occur due to decrease in the blood sugar level. So, diabetes is going to occur due to increasing the blood sugar level. Diabetes is going to occur when increasing blood sugar level. So, it's not related with brain or any other nervous issues. So, that is my answer. That should be the answer for this question, because that's the only one, that's the only response which musical therapy is not being used. But we'll check the other two as well. To treat patients with mental stress, it's correct. Mental conditions can be cured by using musical therapy. To treat patients with brain and nervous issues, that is also correct. Brain issues can be cured by using musical therapy. So, my answer is to treat patients with diabetes. A frequency sound that is sensitive to human ears. A frequency sound that is sensitive to human ears. So, hearing range of human is from 20 Hz to 20,000 Hz. From 20 Hz to 20,000 Hz is the hearing range of human. Right? So, we have to select an answer from that range in order to be sensitive to human. So, frequency sound that is sensitive to human ears, 18 Hz. So, 18 Hz is lower than 20 Hz. So, it is incorrect. 200 Hz. Now, that answer is the correct answer. 200 Hz lie between 20 Hz and 20,000 Hz. So, this is the correct answer. Next one, number 3, 30 kilohertz. Here, see 30 kilohertz. K is given. I told you when we are doing the lesson, kilohertz means 1 kilohertz means thousands of hertz. 1000 hertz are equal to 1 kilohertz. So, here 30 kilohertz means 30,000 hertz. So, we can hear up to 20,000 hertz. So, it is incorrect. Then the next one, 200 kilohertz. Once again there is kilohertz. So 200 kilohertz means 200,000 of hertz. So this is also a sound which is not sensitive to human ears. So my correct answer is 200 hertz, which lie in between 20 hertz and 20,000 hertz. Next one. Occasion where modern musical instruments are used. An occasion where modern musical instruments are used. Number one, in a funeral. We don't use modern musical instruments in a funeral. We use traditional and ancient music instruments in a funeral. Devil dancing. That's also incorrect. In devil dancing, we use traditional musical instruments. Number three, in pirit chantings. That's also the same. We use traditional musical instruments in pirit chanting situations. Then the answer should be the fourth one. Yes, absolutely. In a party, like when we are playing DJ music or in an orchestra, we use modern musical instruments. So my answer is in a party. Right. So we'll move on with the next type of questions. So here you are given with blanks to fill out. So we'll see. The first question is, there are blank musical notes. So within brackets you are given 7 and 21. So we know that there are seven musical notes in any kind of a instrument. Next one. When same note is played from guitar and violin. When same note is played from guitar and a violin. When a same note is played from a guitar and a violin, we'll assume that we'll be playing a same music from a guitar and a violin. Okay. So the question is being asked, sound produced is, sound which is being produced in this instance, same or different? Same or different? So my answer would be, it definitely should be different sounds, because violin and guitar are two different instruments. They are producing sound by the vibration of strings. But even though those two instruments are different, one has one quality of sound, the other has another quality of sound. So therefore, their sounds are different even though we are playing the same musical tone from those instruments. So the answer would be different. Different. So when same note is played from guitar and violin, sound produced is different. Next one. The frequency of a male and female voice is blank to each other. Once again, you are given with same and different. So if you take a male voice is somewhat deep. A rough, deep sound is given out by males. If you take females are going to produce more intense sound with high sharpness, right? Females are going to play, or females are going to emit a sharp, high sound. It's because that females have a high frequency than male sound. That's why females are the ones who are most used in singing opera concerts, right? When singing during the singing of opera concerts, during the singing in those kind of incidents, in opera concerts, females are the ones which most often being used. It's because that they are the ones who are having those kind of frequencies which can achieve the quality of opera. So females have more frequency than males. So even though males and females are going to sing the same song, we can identify which sound is emitting from a male and which sound is emitting from a female. So the frequency of a male and female voice is different to each other. Different to each other. Next one, human ear blank to 25,000 hertz. Human ear can hear only 20 to 20,000 hertz. So 25,000 hertz should not, or it is not sensitive. So human ear blank to 25,000 hertz, the correct answer should be is not sensitive. Is not sensitive. Is not sensitive. The sound is not sensitive to human ears. It is not sensitive to human ears. We'll move on with the next question then. Question number 5. Blank is pleasant to ears. So what kind of sounds are pleasant to our ears? Definitely those sounds should be musical tones. So it is given, one is sound in a fair. Sound in a fair. So sound in a fair, it's a noise. It's a huge noise. Vendors are going to shout like this, buy this, buy this. So it's a noise. It's a terrible noise, right? Sound in a fair, it's a loud noise. So it is incorrect. It's not pleasant to our ears. But if you take sound in a musical, it's pleasant to our ears because music is getting produced in a musical event. So sound in a musical. This is the answer. Sound in a musical is pleasant to our ears. That is very pleasant to our ears because music is produced in a musical event. Right. Move on with the next one then. So here you are given with some other exercises. Here you have to explain the reason for the given questions in here or for the given condition. Now let's see how to answer these type of questions. So some sounds which are not sensitive to human are sensitive to dogs. Some sounds which are not sensitive to human are sensitive to dogs. The reason for this thing is there is a hearing range. There is a hearing range of human. Hearing range of human is from 20 hertz to 20,000 hertz. But if you take dogs, dogs have a different frequency range or different hearing range. So therefore, there are some sounds which heard by dogs, but those sounds are not getting sensitive to human because the hearing range of dogs and the human are different to each other. Hearing frequency of sounds in dogs and human is different to each other. Therefore, there are some instances we can't hear sounds, but those sounds can be heard clearly by a dog. So we can write the answer like this. We'll write the answer. So I'll use a different color. So some sounds which are not sensitive to human are sensitive to dogs because hearing range because hearing range of dogs differ from because hearing range of dogs differ from the hearing range of a human. Therefore, some sounds are only sensitive to dogs. So there are some sounds which are only sensitive to dogs, right? It's because that hearing range of the human is differ from the hearing range of a dog. So there can be some instances where dogs can hear the sound but humans can't, right? We'll move on with the next question. So at present, musical bands use modern musical instruments. So I told you that most of the times in modern bands, they use modern musical instruments. It's because that they could record the sounds. And they could digitalize the sound emitted by the instrument. And they can play a sound which is being recorded by using those instruments. So there are different types of benefits when using modern musical instruments, right? So that's why modern bands are using modern musical instruments when playing music. So we can write the answer like this. Modern musical instruments can record sound play a recorded sound play a recorded sound. The sound can be digitalized. The sound can be digitalized. Therefore, modern bands use modern musical instruments. So this is my answer. Modern musical instruments can be digitalized. Means that we can connect it to an electric source and we can give the sound which is going to emit by the musical instrument through a speaker to a large area. And the other thing is that we can record the sounds, and also we can, if you want, we can play a recorded sound by using the digital instruments or modern musical instruments. So that's why modern musical instruments are more often being used by bands. Right. So we'll move on with the next question. When the membrane of a drum is tight, it produces a sharp sound. When the membrane is tight, it produces a sharp sound. So this is a very easy question. We know that when the membrane is tight, it's going to produce a good sharp sound because the frequency of the vibration is high. Because the frequency of the vibration is high, it's going to emit a sharp sound. Right? So the answer for this question is, we can write, when membrane of a drum is tight, frequency of vibrations increase. Frequency of vibrations will increase. So when frequency of vibration is going to increase, it's going to produce a sharp sound. Therefore, drum is emitting a sharp sound. Therefore, drum is emitting a sharp sound because the frequency of the vibrations is going to increase. Right. So that's why this drum is going to produce a sharp sound. Right. Now let's move on with the next question. Even though two people are near to each other on the moon, their voices cannot be heard by one another. Now, astronauts, those are the people who go to space, no? So, astronauts use headphones when communicating. It's because that sound is a thing which it's an energy which need a medium to propagate. Propagate means move or to transmit from one place to another, to travel from one place to another. Traveling from one place to another can be called or can be defined as propagation. So, propagation of sound is dependent on the medium which the surroundings has. If there is no medium in the surrounding, then the sound waves will not be passed from one place to another. What do you mean by a medium? Medium means any kind of a liquid, any kind of a solid, or any kind of a gas. Simply a particle matter. If you take any particle matter, that thing is referred as a medium. That thing is referred as a medium. So sound is going to travel from particle to another particle. If there are no particles in our surroundings, then we can't hear sounds. Now when I am speaking, air particles near this area will vibrate, and due to vibration of those air particles, my sound is getting produced. If there are no air particles in the surrounding, then even though I am speaking, my sound will not be emitted for the people who are around in here. So therefore, it is important to have communication devices or else headphones when communicating from one person to another in moon. Then why does when two people are living in Earth, we can communicate each other without headphones, even somewhat far, even when the person is 10 or 20 meters away from me. When I'm going to speak, my sound can be clearly heard for that person. It's because that our environment in Earth, our environment is filled with air particles. Earth has an atmosphere, but when you go to moon, moon doesn't have an atmosphere. So there are no air particles in the moon. So sound cannot be heard clearly, or sound will not travel at all. Sound will not travel at all, even though the two people are near to each other. So that's why the astronauts should have to use communication devices or headphones when communicating. There is no medium, there is no particle. So therefore, vibrations cannot move from one place to another. In order to travel vibrations, one particle should go and hit the other particle. The vibrations are going to pass from particle to particle when the sound is going to propagate. So therefore, sound cannot be heard even though the two people are near to each other on the moon. That's why that's why the astronauts are using headphones and other communication devices. So we can write the answer like this. Sound propagate through particles. Sound propagate through particles. In moon, there are no any particles around the environment. Therefore, sound will not propagate from one place to another. Therefore, sound will not propagate from one place to another on moon. From one place to another. So here you have to include sound will not propagate from one place to another on moon. So always remember, always you should have to remember, particle medium is very important for the propagation of sound. So we'll write that thing also. A particle medium is important for the propagation of sound. So a particle medium is important for the propagation of sound. Particle medium means any kind of a liquid or solid or else a gas. Any matter, any state of a matter can be considered as a particle medium, right? So this is the reason why the sound cannot be heard. This is the reason why the sound cannot be heard by the two people near to each other when those two people are on the moon. There is no particle medium on the moon, right? Next question. Sportsmen listen to music before an event. Before an event, sportsman is going to listen to music. So what's the reason for this? I told you, music is a thing which calms down our mind and which relax our mind. So when listening to music, our mindset or our stress will be reduced and our mindset will get calm. So sportsmen listen to music because they can concentrate and they can focus on the upcoming event very well. They can focus on the upcoming event very well when they have a calm and clear mind. So therefore, before an event, most of the sportsmen listens to music. So we'll explain this thing. To have a calm and stress-free mind. To have calm and stress-free mind and to focus on the event well. Sportsman listens to music. Sportsman listens to music. So it helps to calm the mindset of the sportsman, right? It helps to calm down the mind and to give out a good stress-free mind. So by that way, the sportsman can concentrate or to focus on the upcoming event. So this is the reason why sportsmen listen to music before an event, right? So that's all about with the explanation part. So in the next question, you are given with several questions to answer, right? Short answers are enough for these kind of questions. You just need to write down the short answers. So the first one, how much is the hearing range of human? How much is the hearing range of human? So you know that hearing range of human is from 20 Hertz to 20,000 Hertz. So we can write 20 Hertz to 20,000 Hertz. So I told you another way to write down this frequency, 20 Hertz to, instead of 20,000, we can use 20 kilohertz. So 20 Hertz to 20 kilohertz. Kilo means 1 kilohertz include 1 kilohertz is going to include 1000 hertz. Okay, right. So bats can navigate even in dark. Explain. Bats can navigate even in dark. Even in dark, bats can navigate. Bats can find their path, find their way to travel. It's because that they navigate through ultrasound waves. My dear children, bats can use, I told you that bats and dolphins are going to use ultrasound waves in their navigation. So to find out their path during the when they are traveling, to find out the path when they are traveling, they use ultrasound waves. So their vision is getting enabled mainly from ultrasound waves. So they use ultrasound waves in navigation. It helps to travel even in dark. Right. So this is why bats can navigate even in dark, because they use ultrasound waves to navigate or to find out the path. Right. What is the frequency of sound? What do you mean by frequency of a sound? What is frequency of a sound? So frequency of a sound means the number of vibrations, the number of vibrations. Frequency means the number of vibrations. The number of vibrations which a source is going to complete within unit time or else within 1 second is the frequency. So within 1 second, how much of a, within 1 second or else within unit time, how much of a vibration, so how much of oscillations are going to be completed refers or reflects the frequency of an instrument, or else frequency of a certain thing. So frequency means the number of vibrations that occur within unit time. So instead of within unit time, we can use within 1 second. Right. So this is, what do you mean by the frequency? The number of vibrations that occur within unit time. The number of vibrations which occur within unit time is the frequency. Next one, write the international standard unit and the symbol used to measure frequency of sound. So we use hertz as the unit to measure the frequency of a sound. So unit is hertz. H-E-R-T-Z, hertz. Hertz is the unit. And the symbol is capital H and simple Z. This is the unit which used to measure the frequency. Right. Next one. Define human range of hearing. So range of hearing means that's the limit of sound which a human can hear. The limit of frequency or the range of frequency which is sensitive to human ears is the range or the frequency range or the hearing range of a human. Right. So what do you mean by the range of hearing or the hearing range of a human? Hearing range means the frequency of sound which is sensitive to human ears. The range of frequencies, the frequencies of sounds which is sensitive to human ears. So, frequency range which sensitive to frequency range which sensitive frequency range which sensitive to human ear is the range of hearing. So within brackets, if you want, you can include the hearing range of a human, which is from 20 Hertz to 20,000 Hertz. From 20 Hertz to 20,000 Hertz is the normal hearing range of a human being. Name two animals that can navigate by using sound waves. So you have to name two animals that can navigate by using sound waves. So I told you earlier during the last part of our lesson, there are two animals who can navigate by using ultrasound waves. Sound waves which has more frequency than 20,000 Hertz. So those two animals are bat and the other one is the dolphin. So the two answers for this question is bat and the dolphin. Bat, dolphin. Bat and dolphin can navigate by using sound waves. Okay, right. Move on with the next question then. So, when playing a serpina keys in right side, when playing serpina keys in right side, serpina means the harmonium. So, when you are playing harmonium keys in right side, it gives a sharp sound than the keys in left hand side. So, if you playing the serpina like this, left hand keys, right hand keys. So, left hand keys is not giving that much of a sharp sound, but when you come into right hand keys, when you are tapping right hand keys, those keys will give out a very sharp sound. So, we will see what is the reason for this. So, you know that there are three, we can divide the musical notes into three categories: major C, minor C and middle C. So, when moving from left to right, frequency of the musical notes is getting increased. This is minor C, left hand side is minor C, right hand side is the major C. So, the reason for this thing is, this incident is, when playing the serpina, the left hand keys has less frequency, but right hand keys has more frequency. So, that's the main reason of creating two different sounds with less sharpness and with a high sharpness. So, when playing a serpina keys in right side, it gives a sharp sound than the keys in left side. So, reason is, keys in right side has high vibration, has high frequency, than the keys in left side. Therefore, right side keys will give a sharp sound. So, keys in right side has high frequency than the keys in left side. Therefore, right side keys will give a sharp sound. So, this is the reason for that incident. Next one. What is the reason for decreasing sound when touching a ringing bell? Now, if you are going to ring the bicycle bell, and now you are going to hold it by your hand, you are going to hold the metal piece by hand. So, in that situation, you can see that the vibration is going to reduce. So, therefore, the sound is also going to reduce. Sound is emitted by vibration of the metal piece in the bell. So when I'm going to touch the bell, the vibrations are going to be interrupt. Vibrations are interrupt. So when I'm touching the bell, while it is vibrating, what happens? The number of vibrations or the number of oscillations will get reduced. Number of oscillations or number of vibrations will get reduced. So therefore, what happens? Due to decreasing the number of vibrations or the number of oscillations, the sound emitted is also going to be reduced, because sound is a type of energy which emits according to oscillations or according to vibrations, right? So because the number of vibrations will reduce when touching because the number of vibrations will reduce when touching the bell So what happens when reducing the vibrations, the sound emitted is going to be also reduced. So because the number of vibrations will reduce when touching the bell, then the sound emitted also decrease. So always remember, sound is a energy which emits or which is going to emit due to vibrations of materials. So if the vibrations are going to be reduced, then the sound also going to be decreased. So that's the reason in this case. So we'll move on with the next question. Name three musical instruments that produce sound by number 1, vibration of strings. So we'll write down. We studied about several musical instruments within this lesson, and there were several musical instruments which produce sound by the vibration of strings. Right, now we'll write down some musical instrument which produce sound by the vibration of strings. So we can write these things: violin, guitar, sitar. So these are musical instruments which produce sound by the vibration of strings. Next one, by vibration of a membrane, by vibrating a membrane. So we are going to write down some musical instruments that produce sound by vibrating membranes. So you know that in here, almost all kinds of drums are going to produce sound by the vibration of membranes. So you can write double drum, In Sinhala we refer this thing as the thumb mettaba. Then drum, rabana, or the large drum, right? So instead of drum, I'll use the large drum. I'll use large drum, right? Large drum. In Sinhala, we refer this thing as the dowler, okay? Dowler, right? So in the third one, you need to write down 3 instruments. Take the slide somewhat up. So 3 instruments which produce sound by the vibration of air columns. So we'll write down air columns by the vibration of air columns. So flute, flute, flute. Then conch shell, haggediya in Sinhala, conch shell. Then trumpet, flute, conch shell and trumpet. So these are three musical instruments that produce sound by the vibration of air columns. So violin, guitar and sitar by the vibration of strings, double drum, large drum and rabana by vibration of rabana. When erasing that thing, I have erased the other one as well, right? So by vibration of membrane, double drum, large drum and rabana. Then by vibration of air column, flute, conch shell and the trumpet, right? So we'll move on with the next question then. Name the factors that affects the frequency of sound in below mentioned instruments. So you have to write down the factors which affects the frequency of sound. Guitar. So in a guitar, first one is the thickness of the string. Second one is the tension of the strings. And the third one is the length of the string. So those are the 3 factors which controls the frequency in a guitar. So we'll write thickness, of strings. Next one, tension of the string. Then the final one, we can say that length of the strings. Length of strings. So there are 3 factors. There are 3 factors which affects the frequency of a sound generated by a guitar, right? There are 3 factors. So I'll erase this thing to check the things. To check the factors which are important for the drum. So I'll erase this thing and take this thing somewhat up. So the next one is the drum. So if you take the drum, mainly the frequency of the drum is going to be mainly depending on the tension of the membrane, and the second one is the thickness of the membrane. So tension of the membrane, then the second one, thickness. of the membrane. These are the two factors which affects the frequency of a sound which generated by a drum. Right. So I'll take the slide somewhat up. Then the next one is the xylophone. So xylophone, it has several metal bars with several lengths. So length of the metal plate or the metal bar is the one which affects the frequency, is the factor which affects the frequency. So my answer would be length of the metal bars. Length of the metal bars. Length of the metal bars. This is the factor which affects the frequency. Length of the metal bars. This is the factor which affects the frequency of a xylophone. Then the next one is flute. Flute is really simple. Here we need to change the length. Here we need to change the length of air column. Flute is really simple. We need to change the length of air column in order to change the frequency. So length of the air column. Length of the air column is the factor that affects the frequency. Okay. Right. Now let's move on with the next question. So the question number 5. In given two figures, two strings of guitar can be observed. Now there are two strings of a guitar. You can see that a thickness of the X string is somewhat greater than the thickness of the Y string. Okay. So therefore, when increasing the thickness, frequency reduces. So therefore, remember in X string, when vibrating the X string, it should produce less sharp sound as it has less frequency. When vibrating Y string, it should produce more sharp sound as it has more frequency. So which string has the most frequency when vibrating? So it's really simple. Our answer should be Y because it has less thickness. So Y is the answer. Right? Y is the answer. Y is the answer. Y string has the highest frequency because it has the lowest thickness. Y string. Second one, explain the reason for your above answer. So my reason is because the thickness of Y is less than X. Thickness of Y string is less than X. This is the reason, right? When reducing the thickness, it will vibrate more fast and produce more sharp sound, means the frequency is going to increase, right? So let's see what are the other questions. From above strings, which one produces the most sharp sound? So that answer is also obvious to us. It's because that the more sharp sound is getting produced when the frequency is high. So select the string which produces a more frequency when it is going to vibrate. So Y string is the answer because it has a low thickness. So it produces a sharp sound because it has a high frequency. So answer should be again Y string. Y string. Then finally you've been asked what is the final conclusion that can be taken from the above experiment. So from this above experiment, when we are playing two different strings in a guitar, what is the final conclusion that we can take? So here the final conclusion is when thickness is high, sound produced is not sharp because the frequency is low. When thickness is high, sound produced is less sharp. Less sharp means less intensity. Okay, less sharp means less intensity. So sound produced is less sharp because the frequency is low. Because the frequency is low. So this is my final conclusion from the activity. From this experiment, this is the final activity. This is the final conclusion that we can come up with. When playing a metal or else a string that has a high thickness, right, the sound produced is less sharp because the frequency is low. So in reverse case also you can write the conclusion like this: when thickness is low, sound produced is more sharp because the frequency is high. So we can write that thing as well. I'll write it. Second point, when thickness is low, sound produced is more sharp, or else we can use just sharp. Sound produced is sharp when thickness is low. Sound produced is sharp because the frequency is high. Because the frequency is high. So this is my final conclusion from this activity or from this experiment. Right, my dear children. So I hope that you got a sound idea about the listen sound. I hope that you have got a sound knowledge about the sound lesson. So we have done several questions regarding the lesson also, and we have discussed all the theoretical parts related to sound lesson with the activities. Right, my dear children? Then I'm hoping to meet you with our next lesson, our 6th lesson. So until then, goodbye for all of you.